And hey, folks, this is one of the problems that's going to be pretty similar to the things that we're going to be doing in Chapter 5. So let's do number 31. Alright, in the helicopter view of this figure shows two people pulling a stubborn mule. So A is going to ask to calculate the single force that is equivalent to the two forces. Now think about this visually, folks. You have this guy pointing the component in the x and this in the other directions. One of them is going to surpass the other. So whatever surpasses is the direction that the component that this horse is going to change, and then both of them are pointing backwards. So both of them are actually. So this guy's going to be moving. So that's because the force is proportional to the acceleration. By definition, I mean, if you're a flat earth, you're a fucking dumbass. So, because if there's an acceleration, that implies that there's a force. So don't say shit like, oh, well, just because Einstein supersedes gravity, even though I don't even believe in Einstein's relativity, but that's just me, though. That doesn't necessarily mean that there's no gravity. I mean... Anyway, I just went off topic. Anyways, a single force that is equivalent to two forces. So the force that a third person would have to exert on the mule to make the resulting force equals 0. All right. So the question is basically asking to find. It's basically part B and A and B are practically the same thing. So part A is going to say that you are pulling the force F1. And I'm going to call this theta 1. And F1 is going to be 120 newtons, with theta 1 is going to be 60 degrees. F2, and I'm not going to really draw them to scale because I don't know which value is bigger or not, but F2 is going to be theta 2 and F2. So the F2 magnitude of that component is going to be 80 newtons. And the theta is going to be 75 degrees. So what we're going to be doing, folks, is we're going to be adding the forces based on its components. And I'm not even going to pause this video. So the resultant F, which I'm just going to call F, I guess, is going to be, or for the X in the X direction. In fact, let me write this. So I'm going to label this F, this vector, as F of X. And I'm going to use the I hats and the J hat notation in the I hat direction, plus F of Y and the J hat notation. This is how I'm going to organize it. And what I'm going to do after that, folks, is I am going to find out what those F of X is and F of Y, because I like to find them separately. So F of X is going to be this component right here. And I'm going to use blue here. I'm going to change a little bit of color. So F of F is going to be F1 cosine of theta 1. So notice that this is what we're looking for, this component right here. And then we're going to minus, because we're going to go in the opposite direction of the component of whatever that is, F2 cosine of theta 2. So notice, folks, that all we're doing is adding the components. That's what vectors are, folks. That's what trigonometry is. It's just getting those components, and that's F of X. F of Y is going to be, and we're going to do the same thing. We're going to take the Fy, we're going to add both of these guys. We're going to call the both direction upward, F1 sine of theta 1, and F2 sine of theta 2. Because normally I don't show all the steps, but since I want to show as much work as possible, I might have to redo these videos, so maybe I can cover these topic a little better. But this is important to get to really get a hang of this, folks, because all we're doing is finding what those vectors are in the components. I already labeled the variables, what those variables are. I'm going to put this in the calculator, and then we're going to find the resulting force. So once you get the results, the vector F is going to be 39 point, and I have this stored in my calculator, 39.29 newtons in the I hat direction, added to 181.19, or I'm going to put 20 newtons in the j hat direction. So I guess you could, the force the third person would have to exert on the mu to make the resulting force. No, the single force that is equivalent to two forces. Well, there's the single force. Now, let's get the magnitude and the direction, and I'm going to put that all in part A, I guess. I would just, might as well, I like to just write the components, but if they want the magnitude of F is going to be 185.41 newtons, according to this, and the angle should be pretty straightforward. So you don't even have to like minus or plus or anything of that sort. So the angle is going to be 77.8 degrees. So this is going to be the resulting force that this guy would have to exert in order for the vectors to be zero. So I'm going to erase all this now. So notice that all we did is find the components. Now for part B, part B is a bit strange because what we just found, folks, is this. We found the component, we found the resulting force F. We found out that this is going to be 185.41 newtons, and this angle is going to be 77.8 degrees. So that's going to be the resulting force equivalent to these two forces being added. Now the question is asking the force that a third person would have to exert. So let's take another person, and what force would that person have to exert to make this value zero? So we can already say that this would have to have the same magnitude of 185.41 newtons. Now it's just a matter of which direction this thing would have to exert. So I think you could do, you would have to pull in this direction. So that's going to be a negative down, so negative in the x and y downward, in the negative downward. So that means that you're going to take 180 added to whatever that angle is. So I think this is going to be the answer right here, 257, if I were to guess. If I'm wrong, whatever. I'm not even going to bother to check, but, you know. But this would be the angle that this guy would have to exert in the opposite direction. Notice that all I did is took 180, added to that particular angle to get to that component. So if you take that angle, we can verify this. We can take that magnitude that we found and put cosine of 258 degrees. So that should be negative x, and then you could take that angle, add that, and that should be approximately y. So both of them values should be negative and negative, and they are. So, you know, it's just getting familiar with your vectors, folks. It's nothing more.